But at least the video is there, so you can at least watch the video and just recreate all the files and all the points.
Can we go over the homework before the exam?
Yes, we are going to go over the homework first. Okay, well, let me go ahead and get started. I'm not taking row today, because I forgot to take the row sheet again, which is okay. It's another shotgun that I give people to shoot themselves in the foot. Okay, so let's go ahead and work on this one. We have the same 16 combinations. Some of those, you can work it out the same way as in addition, and some are different. Okay, so with subtraction, I think the ones that are the most different will be anything that involves the overflow flag will be quite different, and anything that involves the carry flag will be a little bit different. So those are the ones that are a little bit different from last time. Just like last time, I will do it the same way. You'll use a text editor to basically document all the cases for each one, and if it is not possible, we'll go ahead and explain why it is not possible. Okay, so we have all these cases, and this time I'll just use a different format. I will just use an example right under that, so that way I don't have to check each one. It's a little bit easier that way. Okay, we want all flags to turn off. Would that be hard to do? Okay. Y minus 0 would do it. Okay. I just want the sign flag to turn on with everything else turned off. Would that be possible?
0 minus 1.
Negative 1 minus 0 would do the trick, because negative 1 itself is going to have the sign flag turned on. Minus 0 will not generate a borrow. It will not overflow either. Okay, so it will preserve everything. So that's why the sign flag is going to turn on. I want just the overflow flag to turn on. Okay, is that possible? Okay. So with the overflow flag, what we want to do is to remind ourselves what is the overflow flag and how it is defined. Okay? The overflow flag, if you look at the bitwise operation, okay, let's say that we have y minus x equals d. Okay, that's the equation. And we'll just use the same y and the same x and the same d to mean the most significant bits. So I'm kind of overloading the symbols here a little bit. So that means if y is negative and x is non-negative, and somehow you get a result that is non-negative, then we have a problem. Okay? Because I'm looking at the most significant bit here. The most significant bit of y being 1 means that the number is representing a negative value. X is representing a non-negative value. If I subtract a non-negative value from a negative value and somehow end up with a non-negative value, the sign does not make sense. So that's the first part. The second part is just the opposite. Y itself is non-negative. I subtract a negative value from it because x has the sign flag turned on, and somehow I end up with a difference that is also negative. That also does not make sense, because when you subtract a negative quantity from a non-negative quantity, the result should be non-negative. So that's the two cases. They're basically, they're definitely exclusive of each other. This is one case, and that's the distinct case, the other case. So in this case, we want to make O turn on, so which means we want one of these, but we don't want the sign flag to turn on. So immediately we know that we have to look into this one. Because the other one, if you look at the other one, the one on the right-hand side, D is by itself without the negation, which means the most significant bit of the difference is a 1. And that will turn on the sign flag as well. So that's why we can forget about the second one. We have to look at the first case. So in the first case, y is negative, x is non-negative, and somehow we end up with a non-negative value. The only way, or one of the quickest way to make this happen, is to overflow it. Okay, you're basically making the result so negative that it cannot be represented using a 32-bit number. And to overflow it, you can just pick the most negative value that you can find, and what would that be? In bitwise representation, it is represented by 80000000. That's the most negative value that you can represent. If you subtract just 1 from it, it becomes a value that cannot be represented using 32-bit as a signed integer. And this number is going to be 7FFF. Okay? And in that case, only the overflow flag will turn on. The carry flag or the borrow flag in this case does not turn on, because if you look at these bit patterns as an unsigned interpretation, this number is huge, whereas the second number is really tiny. So the borrow flag will not trigger. The Z flag does not trigger because the result is non-zero. The overflow flag triggers because it fits this particular pattern here. And the sign flag does not trigger because 7FFF does not have the most significant bit turned on. Okay, is that okay so far? Okay. Now, the next one, this one here, is really basically the same thing, except this time we want the sign flag to turn on. Now, it gets a little bit more tricky this time, because if you want the sign flag to turn on, we have to look at the right-hand side of this equation here, because we want the sign flag of the difference to turn on. So this means the first number has to be non-negative, the second number has to be negative, and somehow we end up with a result that is also negative. Okay. Why do you think there's a problem here? Because the borrow flag is turned off here. Okay? And those two it's not possible for this to happen without triggering the carry flag. Now, why is that? I mean, if I want to explain why this is not possible, how can I possibly explain this? Well, we can explain it just by looking at the bit pattern here. Because we have y minus x, and we have the intermediate row here. And this is the borrow from before, from the previous digit, from the previous bit. And then we have the d here. Okay, that's the general format of a subtraction. So the question now is, if I know y, okay, according to this part here, if I know y is a 1, okay, because are we okay? Do we know y? I can make y 1. Yeah, because that's the only case that can make the result happen. Okay, if I make y 1, x has to be 0, and the d has to be 1. Remember, I'm only looking at the most significant column of the subtraction. I'm not looking at the entire thing, just the one vertical slice that represents the most significant bit. Okay. Now b can be 0, can be 1. Okay. It really does not matter. Why don't you think it matters at all? Actually, we know this has to be a 0 too, but it won't trigger the carry flag. So in this case, 1 minus 0 is what? 1. 1 minus 0 is 1. So the carry flag is actually not triggered. So that means it has to be possible. So that means the other one, when we see C, O, and S at the same time, that one would be impossible. Is that making any sense?
No, COS works.
COS works too?
Yeah.
Well,
No, this one doesn't. This one doesn't work.
That's not an overflow right there.
Yeah. 'Cause
Oh,
look,
that's right. Okay.
Yeah.
In order to overflow, this one has to be a 0.
But you
Yeah.
need it to be signed, so you have to change that to 1 and change the other one to 1, and then change the first one to 0.
Oh, okay. I see. Oh, and I'm looking at the wrong part. Am I?
Yeah, we're about to say you just proved it right.
Great, there goes that one. Okay, so we want the sign to be on. In order for the sign to be on for the difference, we have to be looking at the second case. Okay, never mind.
Good thing we never trusted you anyway.
Operator error, so it has to be a 0, 1, 1.
Yeah.
Alrighty. Okay, so forget what I just said. Roll the tape back and erase over. So it has to be a 0, a 1, and a 1 down here. That is, that means, this 0 minus 1 will automatically trigger a borrow already, regardless of the rest. And that's it. Okay? Am I doing okay? I mean, I know it's a little bit confusing because I looked at the other part of the equation.
Sort of getting that wrong.
Mm-hmm. But this is the proof. Okay, if I want to prove that this is not this pattern is not possible, this would be it. Okay, and once again, let me just explain that again, just in case the confusion cause people to kind of miss this part. Okay, this is the combination. I want the sign flag to be a 1. In order for the sign flag to be a 1, the sign flag, the most significant bit of the difference has to be a 1. I also want the overflow flag to be a 1. In order for the overflow flag to be a 1, and I rule out the case that the sign flag of the result is a 0, this is the only combination that I can use. Now fortunately, y, x, and d, they're all single bits. So that means I have just narrowed down the most significant column of the subtraction. I know y, the most significant bit of y has to be a 0, because otherwise not y would not be a 1. We also know the most significant bit of x has to be a 1, and the most significant bit of the difference also has to be a 1. So that means when I write the slice, when I write the slice for that particular row, column of division, I have just fixed this bit here, which is y. I fixed this bit here, which is x. I also fixed this bit here, which is d. Now, just by fixing these 3 bits, just for fixing these 2 bits, means that there has to be a borrow. The carry flag has to turn on, which conflicts with the pattern that I'm looking at here, because this pattern specifically said that the carry flag has to be off. And that's enough proof already. Is that okay so far? How many people kind of use this same line of explanation? Okay. Okay, here's the next one. The next one is xzxx, which means the carry flag is off, the overflow flag is off, and the sign flag is off. This is easy, right? Just about any number minus itself will do it.
Or 0 minus 0.
Or 0 minus 0. But 0 is a part of any number. So I would just pick a number here. Let's pick 13 minus 13. Okay, that's good enough. Well, this one
Let's test it
is
and
not
be
possible.
sure.
Sorry?
Let's test it and be sure.
Let's test all 4 billion combinations and make sure that it works for every single one of those integers. Okay, the next one is not possible, but you can use the same explanation as in addition. Okay? Has nothing to do with subtraction or addition. It has to do with when you have the sign flag turned on, it means the most significant bit of the result is a 1. But in order for the z flag to turn on, they all have to be 0. So in other words, the 2 flags automatically conflict with each other. Has nothing to do with whether you're dealing with addition or subtraction at all in this case. Okay, so we can just say z equals 1 conflicts with s equals 1 because s is the most significant bit of the number, and it has to be 1 for sign to be 1, but it has to be 0 for z to be 1. So it basically generated a conflicting case. Okay, how about this one here? Can I have the overflow flag and the z flag to be on at the same time? No. Nope. But how can I explain that?
0 can only be obtained by subtracting a number from itself, therefore you can't trigger the overflow flag.
But how do you know 0 can only be triggered by a number subtracted itself?
Because we've all taken math.
Yes.
Because you're subtracting something of equal from something else that equals the same thing, so they have to cancel each other out equals 0. Unless it's a negative, right?
Go ahead.
Well, the proof I did was like the 0 flag, in order to turn it on, the numbers gotta be equal to each other, and then the overflow, you have to subtract different numbers from each other to turn it on.
Well, what I would do is I'm going to go back to the definition of the overflow flag. So we have 2 distinct cases. I can basically throw this out and say, okay, that's probably not a concern of me, because in this case, the most significant bit of the difference is a 1 anyway. So I know this will not give me what I need. So what I need to do is to look at this case here and say, okay, if this happens, how come the 0 flag won't be off? Okay, so let's take a look here. Let me just kind of slide back here. In order for the overflow flag to be a 1 and the z flag to be, okay, let me just, in order for the 0 flag to be a 1, okay, we have to basically use the other part. And O to be 1. So we want this to be a 1. But in order for this to be a 1, we are looking at a number like this. 1 minus 0. This is the most significant column again. Okay. And we don't care. Okay, we know what this row is going to be about. We also have a B here, and then the final result, and we want that to be a 0 here. Okay, so this automatically tells me that it is not possible for the entire difference to be a 0, because 1 minus 0 is what? Is 1. So that means this B has to be a 1. Now, how can I make that 1 happen?
By borrow from previous subtraction.
Yep.
Which gives you 1.
Yep. So that means those two numbers have to be different. If you have the same numbers, the two numbers cannot give you that. But when the two numbers are different, it will also make sure that the result is 0 to begin with, because particularly because of these bits. Is that okay? I mean, what about the next one? The carry flag is off, the Z flag is on. Same explanation, right?
Zero sign.
So basically anything that has CO in it is automatically explained.
And Z.
Yep, and CS. So we, okay, C, ZO, or ZS. How about this one? Just the carry flag is on and everything else is off.
Yep.
Okay. And that can be generated by, the carry is on. Okay, so this one you have to be careful because this won't work. This will trigger the sign flag to be on. So let me just copy this one to this guy here. Okay.
0 minus 8. 0, 0, 0, 0, 0, 0, 0.
You need a bar to clear the sign flag. You need a bar to clear the sign flag. Let's say that one. C by itself. You go 0, 1, and it comes out with a 1 with the carry. But if you borrow from the previous one, that will clear from the second significant bit. That'll clear the sign flag, and this carry back flag will be on.
Yeah, you just have.
I don't remember what number it is.
Yeah, I just have to remember what number would generate this case.
6 6 0 0 0
I had 0
0 0. Then F 0
Okay.
That's an odd answer.
Right?
0 minus, and then you can do hexadecimal C with all zeros.
Does that do it?
I read binary.
Hmm?
I wrote a binary.
But this will do it. Well, let's double check and make sure that this will only turn on the carry flag. Okay, if you have a suspicion, you can always double check and not use the debugger either, right? I mean, you want to be able to do it by hand first and then use the debugger only to verify the result. Okay, when I subtract 80000000 from 7FFF, we know a borrow is going to result. Okay, so I know for sure the borrow is going to be there. The result is also going to be non-zero, so that means the Z flag is going to be a 0. So we are okay with those two. How about the overflow flag? Is the overflow flag going to turn on in this case?
No.
It's not going to turn on because we have a non-negative number minus a negative number, and then the result is what? The result is non-negative. Okay, so the O flag is turned off, the sign flag is turned off, so this is one combination that would work. Question? No. Okay. And then this is the next one. 0 minus 1 will trigger both the sign flag because the result is -1, and it will also trigger the borrow because 0 is less than 1. Okay, 0 is less than 1 whether signed or unsigned, so that will generate the pattern. The carry and the overflow by itself. It's not possible because of the.
You can't do it without having a sign flag.
Yeah, the sign flag will turn on whenever the carry flag turns on. So you can use basically the same explanation as this one here. It's the same, basically. You're still constrained by the same bits. that. Actually, yeah, I cannot just copy that because this is actually using the other case. Okay, if you look at this one here, the sign flag is off. If the sign flag is off, I have to be looking at this one here. If I look at this one here, I'm basically looking at 1 minus 0 as the most significant bit. And this results in 1. Minus another bit here. And then the result has to be, there has to be a 0 here.
That means it has to be a 1.
But that means it is not possible to generate a carry in this case. Because 1 minus 0 does not generate a carry. 1 minus anything does not generate a carry either. This one has to be a 1, but that also guarantees that the carry flag is a 0. So this means most of the answers of the impossible cases can be explained if you just look at the most significant column of the subtraction. This one we know it is possible. We just have to, find a case to do it. So we have to start with a non-negative quantity and end up with 0 minus.
I did 0 minus negative 8.
Yeah.
Because this will result in the same thing with a carry, with a borrow. Okay. Now, it doesn't look like this will generate a overflow. Why do you think this is going to generate an overflow?
It's positive minus negative is negative.
Being the negative. Yep. This one is not possible. Okay? But why is it not possible? How would you explain this is not possible?
Because you can't carry another 1 being somewhere.
Same reasoning as before.
Okay. Kind of.
Yeah, kind of.
Kind of. Okay, this one is just easy. This one is easy too because we have already explained how the Z and the sign flag cannot both be turned on regardless of the rest of the flags. We also have explained how the ZO cannot be a combination. And the next one is, well, we can see a whole bunch of combinations, right?
Yes.
We're about to prove this one.
Or
Yeah.
CZ.
So, or what?
CZ will also be a reason why that one's not one.
Okay. Yeah, but you can use any of the previous combinations. Okay.
Yeah, basically 0 is not possible.
So are there any questions about this particular homework assignment? Yep.
When are they going to be graded?
That's a good question.
Spring break.
Spring break. I'm hoping that we can get it done before spring break. Once I have a template, script to do one, I can use, I can just modify the same script to do the other ones. So once it's done, it's easy. It's just be procrastinating.
If you're as bad as we are.
Well, at least I explained the answers first.
If
Which is
you
important.
want me to write a script for that, I'll be glad to.
Print 100%. 49 times.
Actually, I think it's just return 1.
Return 1 or return 5.
I've got most of that script already written.
I have it already written. I just have to adapt it to this semester because I don't really exactly use the same pattern every semester. Okay, let me make sure I save this file. Well, the script is actually kind of interesting because it is a combination. It's a Perl script on the outside, but the Perl script would also rely on the GDB script in the inside, so that you can run your program, using a GDB script, and then the Perl script will capture the output from GDB running the GDB script, and then compare that to what is expected from the program. So it's kind of cool.
Yeah, that's exactly what I do in a make file.
All right, so the homework is done, and now we are going to move on to the exam, the practice test. The practice test is up, already here. It's in topic 4. And it looks like an assignment, and that's the way it will be next Thursday. Okay, so on next Thursday, when you look up, it will have the same format, but obviously it won't be open until the time it's supposed to open. So the format is almost the same as most of your homework assignments. You have to download the file, upload it to the virtual machine, extract the files on the virtual machine, and a folder will be created. The questions are embedded into each source file. There are 4 files in this case, question 1 to question 4. Finish these questions and use the command, this command here, to create the answer toggle. And then once you have the answer toggle, you have to download it back to your PC, and then from the PC you upload it to Moodle. Essentially, it's the same way that you turn in any homework assignment, except in this case, there are 4 files inside a folder that has to be inside the archive. Okay, any questions about this part? Okay, let's go ahead and do it. I'm not going to run a virtual machine to do this, so I'm just going to use my live distribution. But when you use an actual virtual machine, it'll be about the same, except I don't have to upload the file into the virtual machine. That's the only difference in this case. So I will go ahead and save link as. Now, the other thing I can do is I can just open the file, because I have all the tools to expand the file on the fly and copy everything to the folder. But I'm not going to do that. I will save link as, so I can show you exactly what you have to do to run this command. I will save it into my root account, which is what you should do with your virtual machine. And it is done. Switch back to a command line interface. And the command you have to run to decompress the file is xzvf. I'm hoping that by this time I don't have to write all the instructions, because most of you should kind of know or can look up how to do it. And the file is called px1 for practice exam 1. And it creates a folder. The folder is called px1. It has 4 questions inside it. Each question is a source file.
Why did you go 2, 3, 4, 1?
Because I think these are organized by dates.
Okay.
So I might have gone back and changed one, at the end. Okay, so we can now take a look at these questions. Question number 1. You are only allowed to fill in the blanks marked by the question mark. Do not add $sign or the % symbol to change the operand type. The solution may not be unique, or in this case, it is not unique. When the program stops at checkpoint, EBX should have a value of this, mess here. So how do you get started? Yep.
First, we need to know what type is that value. Is it binary, integer, octal, or it can't be octal?
Is it
Is
decimal?
Is it this
It
Decimal.
doesn't have any prefix.
So it's this.
So you left out your prefix. We can't trust you.
So first we need to convert it into hexadecimal.
Well, if it doesn't have any prefix, you have to convert it into hexadecimal
Yeah,
first
And then
to
go
see the
because
individual
others are-
bytes,
yeah.
right? But you also want to take a look at the program. The program starts with a no-op instruction so that you can put a breakpoint on the very first instruction here. This one, there's no question mark, so this one has to be done the way it is specified. We are moving a direct operand. In this case, we are moving 4 bytes at label L1 into EAX. Those 4 bytes just turn out to be L1 itself. Okay, there's nothing saying that it cannot be done. It's just that in most cases, people don't do it this way. The next instruction is a move long instruction to move something into EBX, and then we have a move word instruction to move into BX, and the last instruction is a move byte instruction to move something into BL. Okay, so let's go ahead and just make sure that we can assemble the program. I comment out the 3 lines that have the question marks, so later on I will fill in the blanks. So let's go ahead and assemble the program first.
GDB.
Oh,
You said-
Yeah.
no, it did not. Did it complain?
Yes, G1, no such file or directory.
Okay, Q1. Okay.
We'll run it anyway, but
It's not basketball.
Okay, so there are several things you have to do now, because the first thing is to print this out as a hexadecimal number. So one thing you can do is to say print /x, and then just paste that number in. Ah. Okay, right click.
You
I
can't
need
middle
to
click?
say-
Oh, you're using terminal.
Yeah, I'm using that terminal, so that won't do it. So I have to copy.
Terminal
and paste.
sucks. It breaks middle click.
Okay, there we go. Okay, so here we have the hexadecimal representation of this number. And remember, every hexadecimal digit is 4 bits. So 2 of them will make 1 byte. So that means we are looking at 4 bytes here. 00 is the least significant byte. This is the next one. This is the next one. And 56 is the most significant byte. Our first thing to do is the first instruction. The first instruction that we have to figure out is how do we get this part into EBX first? Because this part of EBX can only be done using a move L instruction. Okay, so can we find that particular pattern in memory? That's the first part of the question. So what I can do is now I can print out the memory content. You should be able to do this by hand too, without a debugger, because if you look at the dot in, the dot byte, the dot word, and so on, you should be able to come up with the memory layout already. So let me try to do that. First, is to use just memory layout to help me figure out this part first. Okay, so I'm gonna get out of GDB, and this way, I'm just going to explain the layout of memory. This one is a little bit tricky because I did not give you the leading zeros. Okay, a dot int is a 4-byte thing. A 4-byte thing will have 8 hexadecimal digits. I only give you 6 because the leading zeros, the 2 leading zeros, they do not have to be there. So this means if I look at memory layout, the first byte is which byte? 56. Okay, because it is using a little endian convention. So we have 560023 and one more 00 here. The next row is going to have, let's see, it's just 2 bytes. So 23 is the first byte, and the 56 is the other byte. This one here is L1, and I cannot determine what L1 is going to be until the program runs. So I can only say that there are 4 bytes here. But whatever they are, I don't know until the program runs. And that can change also. Every time you run the program, these 4 bytes may not get the same value. So you cannot rely on the values of these 4 bytes. But I know for sure it's going to take up 4 bytes. Over here, the first word is 23, but since it's a dot word, it's actually 0023. So when you write it out in terms of byte sequence, you have to spell out the least significant byte first, which is 2300, and then you have 5600.
There's half of it right there.
Hmm?
That's half of it right there.
Yeah. Well, you just have to kind of put it in the right order and stuff like
Can we
that.
just do that?
And as I said, there's no unique answer, so there are multiple ways to do it. This one is a real dot int, so we spell out the least significant byte first, the next one, and then the most significant byte. So these are this is the memory content once I run the program and have the dot data portion initialized. Do we have any questions about the memory layout or why it is explained this way? No questions? Okay. Does anyone remember what I'm actually looking for?
56002300.
Yeah.
Okay, 56002300.
So
So
there it
it
is
looks
up
like,
top.
oh, it's all done already, but this is in the opposite order.
Yep.
Okay, because of the little endian convention, this is actually in the opposite order. So we have to find a sequence that is, but I don't even care about the 4 bytes. I only care about the most significant 2 bytes, which is 56 being the most significant byte, and then 00 being the next significant byte. So that means I'm only looking for 0056. Okay, so there are plenty of 0056. There's one here, and there's another one here. Okay, so you can pick either one. Either one will work. I'll just pick the first one here. Okay, now even though this is the part that has to go to the most. Okay, let me just highlight the portion that I am referring to. Even though these are the hexadecimals, digits that I want to put into the most significant 16 bits of EBX, I cannot copy from this location. Because if I copy from this location, then these 2 bytes will in return, they work the same way. Okay, well, so either one will work. I can either start here, or I can start here.
So start
Either way
there.
will work.
Start there, because that gets us 2 copies of the right thing in the right order in the right place.
But no, wrong place.
Sorry?
The second bit 6 with the wrong place.
They're still wrong.
Yeah.
Yeah, in either case, it won't get everything done in one shot. Plus, you still have the mandatory move W and the move B anyway. So even if you did it the first time, you still have to worry about the second and the third instruction.
Yeah,
So you can pick either one in this case.
Then either way, we're right, even if we get our Indianness confused, because we keep forgetting which way is which.
Okay, let's just say we take this byte here. What is the address of this byte?
L1 plus 3.
It's L1 plus 3.
3
So
EAX.
that means, if I am going to change this one here, I can specify a 3 here. Okay? Now, if you're fairly confident about your understanding of memory layout and stuff like that, you don't have to go back to the debugger, to just look at the effect of this one single instruction. But I'll go ahead and do it anyway, just in case people want to get confirmation every single step, which is not a bad idea, but it does take up extra time.
You won't compile.
Well, junk.
You want the symbol.
Or comment. There we go. Okay, so this time I just want to stop at line 17, right before the instruction that I want to execute.
Why not just B checkpoint?
Yeah, I could do that too. Single step, and then I want to look at EBX. Now EBX doesn't have everything right. It has most of the stuff right. It actually has 3 of the 4 bytes done already. But the most important part is 5600 is at a place that they have to go. The next 2 instructions will overwrite the least significant 16 bits anyway. So at this point, I don't even care that what is the bit pattern in the least significant 16 bits. But this is a good confirmation that we at least get the first part done right, and we can go back to the file and then figure out, okay, what do we do with the next instruction? The next instruction has to move 2300 into the least significant byte or the least significant 16 bits of BX. Okay. Well, it doesn't have to be 2300. It only has to be something something and then 23. 23 has to be the most significant byte of the 16-bit pattern. And how many 23s do we have here? Quite a few. And you can pick any one of these. Okay, you can pick this one here. Then you have to use a negative displacement. Let's go ahead and use this one, just so that we know
You can
how
also
to use
keep the current displacement and use a 3 again. You could use a 3 again.
And you can use the 3 again. Yep. But I just want to show people that you can also use a negative displacement. So this will be, okay, this is -1, -2, -3, -4. This is -5. Okay. So that means, even though it is not necessary to go through all these calculation, but -5 should work. Okay? Because -5 will specify these 2 bytes. This is the least significant byte. This is the most significant byte of the 16-bit pattern. And I only care about the most significant 8 bits because the least significant 8 bits will be overwritten by the next instruction anyway. So let's go ahead and run this program again. This time I will do the shortcut. The shortcut is to put a breakpoint at checkpoint and then just run the program. And then take a look at EBX. And sure enough, this is already what we want, but it doesn't mean that you're done, because if anyone turns it in like this, we'll lose points because the last instruction is not specified. You still have to figure out, how to overwrite the 00 with a bit pattern of 00. Okay?
Aren't we supposed to comment our work?
Remember, this is just a sample of the sample question. It shows you what kind of question you'll be getting. it does not reflect the difficulty level of the actual question.
I was gonna say, this would be 5-10 minutes tops. And most of that time is booting up the Brookings machine.
Okay, so in this case, there are plenty of zeros to choose from. We can pick any zero.
Let's choose the address 0.
The address may not have a 0. So let's pick this 0 here. No, I don't care which one we pick. So this is L1, L1 plus 1, L1 plus 2, L1 plus 3, 4, 5, 6, 7. This is L1 plus 7. So if I want to, I can choose this one to be 7. And you do the whole thing. Run the program, take a look at EBX. It's all good, we're done. Yep.
Why don't you make a .gdb init that has b checkpoint 1, enter R, enter IR, EBX, enter quit in it to save us some time?
Then you guys don't have to learn how to use GDB.
But you'd be teaching us how to use GDB more efficiently.
Okay, here's the second question. The second question is something that most of you probably know how to do already because intentionally or mostly unintentionally, you have seen these messages. Fix this program to eliminate all warnings and all errors from the perspectives of the assembler and the linker. Also make sure that when the program stops at checkpoint, EBX should have a value of 0x2424. Okay? So the first thing we want to do is to get rid of all the errors first. Okay? Some of these you can spot right away, and some of these you may not be able to spot right away. So the quickest way to do it is to rely on the tools, and that's why we have the tools. The first time, I won't even bother with G-steps because I know the program is not going to compile. If it's not going to compile, whether you specify G-steps or not is not important. So we'll just say A as. No, it's just force of habit here.
We should write a make file that has that in it.
Okay, and right away we have some problem. Okay, it's really nice because it tells us which lines we have problems with. We have a problem with line 10, error, junk, EAX after expression, and then we have another problem on line 11, warning using %EAX instead of BX due to L suffix. Okay, so let's take a look at those two lines. Let's just say that we cannot even interpret the meaning of the error messages. Okay, so we'll just go ahead and look at the file and then go to line 10 and line 11 to see what is wrong with those two lines. This is the first line and this is the second line. Let's take a look at the first line here. What is the problem here? There's no percent inside the parentheses. Now, the error message didn't say anything like that, did it?
It said junk EAX.
Exactly. Okay? So that means you have to know what, so that means if you don't understand the error message, you have to go to that line and actually manually figure out, this is the problem. What is the problem with line 11?
That you're moving long.
It's conflicting, right? So if this is conflicting, I have two ways to fix it. You have to figure out which way is the proper way. One way to fix it is to change this to a W. Okay? The other way to fix it is to add an E here. So the question is, which way is the right one? Well,
Probably moving that to a W.
Well, EBX should have a value of 2424. Okay? So we just have to take a look and see what this is going to do. We are moving L2 plus 2 into EAX here. And L2 plus 2.
L1 plus 2.
Oh, L1 plus 2.
The instructions don't say that we are limited to changing certain things. We should just remove everything and change it to move L00 or 0x2424 EBX.
You're not supposed to tell them that now.
But you guys understand, you still have to eliminate all the warnings and error messages.
Would
So you
eliminate
just
most
delete all
of them.
lines, right?
Yeah.
Just delete all the lines that have problems and then just move long $2424 0x2424.
Exactly. Problem solved. Solution found.
Okay, but based on this, we have a problem. Okay, so There are several problems here. One is we don't know how to fix this line, but the bigger problem is EAX this will probably crash. Okay, can you guys see why this is probably going to crash? Because what is in EAX at this point on line 10 after line 9?
It's
A3, F2,
L1 plus 2.
Okay, this is L1, this is L1 plus 1, and this is L1 plus 2. So we are taking these 4 bytes, and then we're taking we're taking these 2 bytes, and then taking these 2 bytes and sticking into EAX. EAX is going to be 12242412 in hexadecimal. Is it going to be a location where we can actually find the pattern 2424? Very unlikely. So that means I have another error here. The error is, this is probably $. This really should have been a move immediate instead of a move direct. Because we need an address. We need an address back to the space that we have in this case in order for this code to work. So that means this is one way to fix it. Now once we fix this part here, what are we going to do with the last line? Well, once we fix this line, can we know what the last line is going to do? We know for sure, okay? So let's see what the last line is going to do for sure. Yep.
Can you repeat why do we need the $sign? I still didn't understand it.
Okay, without the $sign, the program will crash, which means you will not be able to satisfy the last line here. Even though you fix all the errors reported by the assembler and the linker, it's still not going to work because the program is going to, how should I put it? The program will crash on the program will crash on line 10. It won't even get to checkpoint because it is not going to have a valid address in EAX. So that's why we have to fix it this way. This way it will have a valid address in EAX to begin with. And then we just have to figure out, should we do a move L or should we do a move W in this case? Because either one will fix the problem. We'll fix the syntax error, but only one will fix this problem here. So what do you guys think?
Let's try move W and see what happens.
Well, we cannot run the program at this point, can we?
No, you need your .x global start.
And okay, this program is not going to fail, but it is. I have to explain this part here too, because without this part, it's really hard to explain why it is not going to crash or why it has the values that it will have. Basically, when you use memory, everything is zero filled unless you specify, I want this to have a particular value. Okay. So, what is this instruction going to do on line 11? But now that we have fixed the problem by adding a % into the parentheses. Do we know which 4 bytes it's going to copy? We know, sure. This is L1, L1 plus 1, L1 plus 2 is this byte here, which is the beginning of L1 plus 2. But this one has a 2 as a displacement, so this is L1 plus 2 plus 3, this is plus 4. This is the first byte being copied, which means this is the least significant byte, this is the second least significant byte, and then the 2 bytes following the 1, 2 will be the most significant 16 bits that will copy into EBX. Is that okay so far? And that's why I have to give you these 2 bytes too to make sure that you know that these 2 bytes will be 0, because otherwise there's no way to make it work unless you know the 2 bytes following the dot byte are also zeros. So that's why I have to give you this part here. Now once you know that part, then you know EBX will have 0, 0, 0, 0 as the most significant 16 bits. The next instruction only has to fill in the 2424. Okay? So if you only have to fill in the 2424, then which 2 bytes am I going to copy? Now you look at this and you say, but we don't have any 2424s. There's a 24 here and there's another 24 here, but these will be separated by this junk here. Are they going to be separated?
No.
They're not going to be separated because remember, we're using the little endian convention here. This is the first byte. This is the second byte. This is the third byte. This is the fourth byte. This is the fifth byte. So we actually do have a 2424 byte sequence. The 2-byte sequence 2424 is starting with this byte here. Okay? Now how do I designate this byte?
It already does.
It already does. Now if I specify move long, would that work?
No.
Because if I use a move long, it will also copy this junk here. That means EBX is not going to be 2424. It will be 122424. So that means the only way to fix this problem is to change this to a move W and preserve the BX over here. Yep.
And we also need a dot text global start.
Well, yes, but we want to look at the error message first, because that's the other thing. So at this point, we know how to assemble the program, and we have to link the program this time. Okay, so we have Q2, Q2.0, and the complaints. Okay. Now this is not the first time that we have seen this message. Sometimes I forget to do the dot text, and dot global underscore start blah blah blah. So this time it's complaining that underscore start is defaulting to this location because we did not tell the linker exactly where to start the program. Okay, and let's just say that someone says, okay, well that's fine. I will still run the program the way it is, and hopefully it will still do whatever it does, and I'll get partial credit. Okay, do you think this will work?
Yes. Probably. Yeah.
Well, let me show you what the linker is thinking at this point. Okay, because you have to look at things from the linker's perspective. How many sections do we have here? We have one big contiguous section of stuff, okay, which includes both the dot data definition as well as the code definition, which normally goes to dot text, but in this case it's going to dot data as well. The linker will say, I'll just take the first byte of this big chunk of stuff and look at it as an instruction, and the entire program will start execution over there. So what it will do is it will first look at these 32 bits as the first instruction. What are the chances that this is a valid instruction?
Pretty good.
That will not crash the rest of the program, so that your program, by the time it gets to a checkpoint, it will have the result of 2424 in EBX. Probably a little bit slim, okay? Since people are not convinced, you will go ahead and do it anyway, right? GDB, Q2, okay, put a breakpoint at checkpoint. You won't even give me checkpoint.
You didn't even get that far.
No, that's only a warning. I do have the
Can't find any
executable.
code
Says it
sections
can't
in
find
symbol
the
file.
Oh, that's because
It won't let you debug it without the
without the dot text. Yeah. All right. So that means we are not. This is okay. So we have to fix this problem. Okay. So what do we do to fix this problem? First of all, dot text. Would that fix everything?
No.
This will
We gotta
only
try
put
it.
the code into the right section, but it won't define underscore start for the linker. So we still have to remember to do the dot global underscore start. And if you want to misspell it, that will work too.
Really?
Really?
Yep, let's try it. See?
Let's that be a bug they fixed recently.
I think it has
Wow.
to do with, for the longest time, the programmers did not know how to spell global.
Global?
So by the time someone realized and go, oh, global should be spelled this way and not that way, they say, oh, well, I cannot change it now because we'll just break a lot of old code. So we'll just add the new proper, spelling as an optional, feature, so that so old programs will still work the way they're supposed to.
S/global/global/G.
Okay, so we run the program, we stop, we look at EBX, okay, 2424, we're done.
You could have just told us 9252.
9252. You will have a special test the next Thursday. Does anyone else want a special test? No? Okay.
Can you explain more about the dollar sign? Why do we need and how is words with the dollar sign?
Well, the dollar sign means we have an immediate operand instead of a direct operand.
Yeah.
If I use a direct operand, what I copy into EAX is not going to be a valid memory location. So the rest of the program will definitely crash.
But with the dollar sign, it's made I copy the address.
Then you're copying the value, which is L1 plus 2, to EAX. What is L1? L1 is an address, so L1 plus 2 is just 2 bytes after the original address. It's still an address. It's just 2 more than L1 itself. So EAX still ends up with an address that is valid, that corresponds to the area that we have defined.
So with the dollar sign, it means that is the address number, not the value number.
No, that's not what the dollar sign does. Okay, the dollar sign is not ampersand. It is very common for C programmers who take this class to think, oh, the dollar sign is the same as the ampersand. That is not the case. Do not look at it that way. Okay, because the dollar sign specifies an immediate operand, whereas without the dollar sign, it is called a direct operand. Okay, you can kind of look at it that way using the ampersand, but it really is not. When you use the immediate operand, it specifies and says, whatever the expression after the dollar sign is, becomes the first operand. It becomes the bit pattern that you copy to the second operand, or it becomes the value that you're adding to the second operand, or the value that you subtract from the second operand. Okay? When you do not have a dollar sign, it is a direct operand, which means whatever that expression is becomes the address of the byte that you want to copy, to add, or to subtract from, or to subtract. So that's why they're completely different things. And I personally would not look at the dollar sign as if it is the ampersand in C.
So
Yep.
I guess it's kind of the reverse of C. In C, you send a variable and it reads its value, and you can use the ampersand to get its address. But in this, it sends its address, and if you do it with the dollar sign, it reads in the address as a bit pattern. That's like the default. But if you want to dereference the address, you need the percent sign or something.
No, the percent is only used in front of a register name. So when you need to refer to EAX, it has to be percent EAX. If you want to refer to EVX, it has to be percent EVX. Are you talking about the dollar sign or the percent sign?
The dollar sign is what you use to give you the address, right?
No, it changes the operand to an immediate mode, to an immediate operand. Without the dollar sign, it is a direct operand. Yep.
Can you give us a counterexample of where you're not reading the address of something using the dollar sign?
Sure. That's easy. Okay. Dollar is not address of. Not S.
There's a point missing there?
How's that?
Sure.
Yes?
Can you have labels in your program as EBX, BX, BH, BL, and so on and so forth for all the different register names that are
Yes, you
labels
can.
and not?
That'd be awfully confusing.
Yes, you can.
Oh,
You can
the
do
BX
something
and
like
BX.
this. You can say, you can do even better. You can say BL equals 5. Okay? Now, if you have BL equals 5, what are you doing? What are you telling the assembler? You're telling the assembler,
BL.
exactly, I'm defining a symbol. Okay, a symbol is just any symbol. The symbol is BL, and every time you see BL, it's the same as 5. Okay, so in
So
that
it's like
case,
a pound define in C.
in that case, this will not create a problem. As far as the assembler is concerned, everything is good. Okay, now why is this good to the assembler?
Because you're copying
Okay.
it to the address 5.
Because it will just copy it to the location 5, yes. Because the second operand now becomes a direct operand. Okay, it doesn't start with a dollar symbol, it does not start with a percent symbol, it does not have parentheses, so that makes it a direct operand. A direct operand is basically saying whatever the expression is specifying the location. and BL is 5, so 5 specifies the location where I will store the byte that represents 1 in 1 byte. Okay, so this program will assemble. It just probably does not what you want it to do.
Can we
Okay.
run it and see what it does?
It will crash.
He doesn't have his exit command.
Hmm?
You don't have your exit.
No, I can always add the exit command, but I know for sure this will crash because location 5 is not a location that your program has access to.
So it's GPF, right?
Hmm?
GPF.
It will give you a segmentation fault. So,
Why are we building
hey, I can do it
debugging
really
to
fast,
this?
okay? It's not a problem. Oh, okay, I specified it in the wrong order. I
No,
forgot to
you
specify
forgot dash O.
Okay. See, long file names are not the problem.
Now let's
It's
run
only a
it.
problem in Windows.
Don't even need GDB, just /.
Okay, run the program, and it receives a segmentation fault signal, and the line that has a problem, guess what, is the line that we are trying to deal with.
Run it outside GDB.
Hmm?
GDB's breaking.
No, GDB is just catching sig_v.
Or you can run it without, GDB. You can run it, just the way it is. Okay, segmentation fault.
Darn.
Hmm?
Darn.
But isn't that kind of, that's dangerous, okay? Fortunately, most of the time, not all the time, unless I want to trick you guys, most of the time, there's no such definition here. So it will give you an error message, but only by the time it links. Not by the time it assembles, but by the time it links. Because the assembler always makes the assumption and say, I may not have every single definition of all the labels used in this program. Some of the labels may be defined elsewhere. So the assembler cannot complain because BL is not defined as a label because it may be defined in another .o file. So it's only the linker. By the time it links, then it will say, uh-oh, nobody has the definition of BL, and somebody needs to know the definition of BL, and it cannot be resolved. Yep.
If you have it defined, if you've defined BL to mean 5, does %BL still work?
Say that again?
If you have BL defined to be anything, does %BL still work properly, or does it try and
Yes,
use the
it will still
register
work.
of a 5?
No, it will still work. Because when it sees the % prefix, it understands whatever follows has to be a register identifier, cannot be a label. Okay? So
So
that
you
means
can't store a register in a label?
So as promised, when I assemble this program, there's no problem because syntactically speaking, it is still okay. It's just that that symbol is not defined in this file. But when I link, it will complain. In fact, it will complain about line 5 of the source file and say we are referring to a BL that is not defined. So when you see this, when you write a program, you know what is happening. Because I will bet you that in this class of 48 students at this time, I would say about 20 will encounter this at some point in time. All it takes is not remembering to put a % before you specify a register, and something like this will happen. Okay? It's just that fortunately, most of you will not define BL, BX, EBX as labels in your program. If you want to use those as labels in your own program, go ahead. Okay? It's just that it's not very advisable. Okay? Are we doing okay so far with question number 2? Moving on to question number 3. This is question number 3. We place the question mark with an actual number so that when the program stops at checkpoint, IRE flags should display this particular pattern. Okay? So I'm not even relying on my own script, flags. I'm just using E flags itself to reflect what the flags are. So in this case, we have sign, we have overflow, we do not have carry, we do not have 0. Yep.
What are IF and ID?
I believe IF is the interrupt flag. ID I do not know. The interrupt flag is basically saying is interrupt enabled or not, which is not something we have talked about so far.
Okay.
Okay. All right, but getting back to this question, it's a single number. In this case, what do I need to put here in order for the sign flag to turn on, the overflow flag to turn on, but not the other two? The Z flag is easy, okay? Whenever we have the sign flag turned on, the Z flag has to be off. So that one is easy. We do not want the overflow flag to turn on either.
No, we do.
Yes, we do.
Oh, yeah, we want the overflow flag, but not the carry. Sorry. Yeah. Yes, the carry flag.
We'll just add a negative 101 to 100.
No.
The negative 100 will cause problems. If you specify negative 100,
No, 101.
101.
It won't overflow.
101 will work. Can anyone specify the range of values that will make this work? Not a single one, but the range.
Wait a minute.
Anything
Anywhere from which number to which number?
156 to
Down to. You got the other end. How about a
negative
28 will work.
28 will work. Okay? Why would 28 work? It's the smallest number that will work. Okay? If you interpret in the unsigned interpretation, this is the smallest number that will work. Because when you add 100 to 28, you get 128. 128 can be represented in 8 bits, but only in the unsigned interpretation. Because 10000000 represents negative 128 in the signed interpretation. And that's why the overflow flag is on, because it is the same bit pattern, but it actually means negative 128. So you're basically adding two positive numbers, and you end up with a negative number. It's not only a negative number, it is the most negative number you can get with an 8-bit signed number. So this is the first number. What is the last number that will work?
156. 155.
155 is the one. Because if you use 156, it becomes 0. Yep.
Could you explain how you came up with those numbers?
How I came up with those numbers?
Yeah, 28 and 150.
Actually, I take it back. This one would not work. 155 actually would not work because 155 itself, this one is only up to 127, which is the largest positive number you can represent using the signed interpretation of an 8-bit number.
Why wouldn't 155 work? Why wouldn't 150? Oh,
155 would not have generated the overflow.
Oh, yeah.
Because anything more than 127 is already a negative value. If you add a positive value to a negative value, it will never generate the overflow. The overflow will never become a 1. So that's why we cannot go to 155. We can only go to 127, which is the last number that will work. Okay? But the question did not ask you for a range of numbers. It only asked you for one specific value. So that means if you pick any value from 28 to 127 inclusively, it will work. Okay. Any questions about this one? Yep.
On the test, could we change the base to like a base 2 or a base 16 if we wanted to?
Yes, you can change the base. Yep. Because the question is, you have a question mark here, so you can use any base to specify the value for that question mark. You mean for the 100?
Yeah.
You can probably just comment and just comment the actual binary representation. Yep.
Say again, what the number representing from what base is that?
Say that.
I mean the 28, 127 for me is
These are base 10
base 10 of.
because they do not have any prefix in front of them. It's only when you have a prefix in front of the number, then it becomes a different base. If you have 0 in front of it, it's octal, base 8. If you have 0x in front of it, it is base 16. If you have 0b in front of it, it is binary.
So what in matching to 28, 21, 27 is referring to some kind of binary number or something?
It's the number 127.
Those are the actual numbers.
It's the actual number. It's 28. You can.
7 cents.
Yeah. So this line can be used. You can use any of the representation, everything from 7f to 0b 1111 oops 0111 1111 to octal. I hate octal numbers. In octal, it's going to be a 1 followed by 6 ones, so it's going to be 0177. Okay, that's the octal representation of the same thing, because each octal digit is 3 bits, right? So we have 3 ones here, 3 ones here, and 1 additional one here, which is the same as 7 ones. And this is an 8. No, I got it right the first time. Okay, so they are all. So these are the same. They represent the same bit pattern. It's just that you can choose either one of those representation. To me, decimal works just fine too in this case. Yep.
Just as a side note, how can we differentiate well in between octal and decimal?
Octal always starts with a 0. Decimal always starts with anything other than a 0.
Okay.
So that means that's a big trap right there, because if you write a decimal number, but you say, oh, leading zeros do not matter and start with a 0, in the assembler and also in any C and C derived programming languages, it will automatically turn it into an octal representation. Okay, so you would hope that somewhere in the number is the digits 7, 8, or 9, because in that case the compiler will complain and say, this is not a proper octal number. Then you go, oh, that's right, I did not intend it to be an octal number. If your number does not have 7, 8, or 9, then it is a valid octal number, just not the value that you want to represent, which is much worse.
Why 7, 8, or 9 if you have 7?
You mean 8 or 9? You can have a sounds like
Yeah, you could have 7.
Yeah,
But you can't have 8,
Oh,
9,
you can have 7,
A, B, C, D,
just
E,
not
or
8
F.
and 9, sorry. Yeah.
What about A, B, C, D, E, and F?
No, you can't. They're not octal characters.
They're not octal or decimal characters. Okay, so this one is done. Are we okay with this one?
Eh.
Does everybody understand why we have this range of numbers?
No.
Yep.
Well, what happens when you roll over to 128?
You
What
have a
is
signed
the
number.
most significant difference between 127 and 128 in base 2 8-bit representation?
They're the logical amount of each other.
The sign flag. Okay, the sign flag is the most significant difference, because 127 is 0, 1, 1, 1, 1, 1, 1, 1, which means the MSB, the most significant bit, is a 0. 128 is represented as 1, 0, 0, 0, 0, 0, 0, 0, which is a negative number, because the most significant bit is a 1. So that's why we stop right there, so that we do not trigger the sign flag to turn on.
They're the binary knot of each other. They're the binary knot of each other.
They're also the binary knot of each other. Yes. Okay. Question number 4. Question number 4 says, put your code after the label. Your code starts here. And I used the wrong case, so that people cannot complain. Oh, but I tried to put I cannot find that label. Therefore, this
It's Linux, it's case sensitive.
Exactly, unless I say search for that label using turn off case sensitivity and then search for that label. Okay, so you'll put your code, basically sandwich your code between this label and this label here. And there's also a double confirmation here to say that put your code here.
Do we put it before or after that comment?
Replace it.
That one does not matter. You can keep the comment, you can replace the comment.
So we should be
Do
all
not-
on the same line after the pound.
Sorry?
We should be all on that one line after the pound. Never really be online.
Or before the pound. Do not remove or change the labels in any way. When the program stops at checkpoint, register EAX should have the memory content of the 4 bytes at label L1 at the time of the execution of your code using the little endian standard. So that has to be the most specific way of saying what I want to say. You can only use immediate and indirect operands. Okay.
So are
all
you
right.
saying you want us to copy L1 into EAX?
Oh, wait, we can't specify a register?
Oh, I forgot that. Immediate, register, and indirect
Can we do
operands.
that during the exam?
Yeah, because without register, you cannot initialize a register to use indirect. So that's why you have to use the register operand. Okay. Okay. What do you do? Well, let's see here. Okay. The objective is EAX should have the memory content of the 4 bytes at label L1. Okay. So tell me what's wrong with this approach. move L dollar 0x12345678 to EAX. Wouldn't that work? It is. This is immediate, this is register, but it does not work according to the description here. What if I change this label when I run the script? In other words, my intention is to put a breakpoint right here in my script, and my script will go to this location and change this bit pattern to something that you cannot anticipate. And the code says specifically in uppercase, boldface, not boldface, but in uppercase, you have to copy the content of the 4 bytes. Okay, well, but this is the content, right? But this is the content when you assemble the program. When the program runs, there's no way to guarantee that this will be the case, because I can put a breakpoint right here and change those 4 byte locations. So you cannot rely on the initialization. You have to copy the 4 bytes when your program executes. Okay? Is that okay? Does everybody understand, what I mean by this part here? So this won't work. Okay, fine.
Don't delete the dollar sign.
What about this?
No.
Because it is not immediate, register, or indirect. Okay. Let's see here. What about? Oh, I know how to do this. Oops.
It's not a
Someone is going to tell
register.
me this, okay? Someone is going to write this because it looks like it is an indirect operand with an immediate inside and a register. Everything looks good to me. Try to assemble it.
Automatic A.
This won't work because the restriction is if you put anything inside the parentheses to use the indirect addressing mode, it has to be a register. It cannot be an immediate thing. Okay. What about this? Not bad.
First
Okay?
you have to initialize the EAX.
You have to first initialize EAX first. All right. So I'll go ahead and initialize EAX.
Dollar outline.
Why do I need a dollar sign?
Otherwise
First of
you're
all,
copying 1, 2, 3, 4, 5,
First
6,
of all,
7, 8.
otherwise it will not meet these requirements, right? This will work. In other words, this type of question is, I might even give you the actual operand, but then I will say, okay, you can only use these instructions and these operands to accomplish the same thing. In other words, what I would be doing is I will say, it's basically asking you to say, this is how Intel does it because we have a CISC architecture. What if you have a RISC architecture and some of the operand modes are not available? How do you do it? Now, before we talk about add and subtraction, there's not much we can do. Okay, because when you look at the based scaled indexed addressing mode, with just move L instructions, we cannot do it. This is a simple one we can do with just move L instructions. But when it comes to a base scaled indexed addressing mode, we have to rely on addition. Yep.
So in this way, we don't have anything from comparison part and adding with carry in the
But this is the
exam?
format for this case. If I give you, let's say, okay, I don't want to, give you the actual question that I'll be asking. So I'll just say, what if this is a based addressing mode? In other words, okay, I know you guys want to go at this point, but we'll just go ahead and kind of overflow a little bit here. Okay.
Or overflow flags gonna be on?
Is it going to be a carry flag or overflow?
Yeah,
Am I
the
signed or
carry and
not?
comparison.
Hmm?
The comparison is not in the exam?
The comparison so far is not.
Okay.
But I can easily turn the specify a value to make this flag combination happen. That can use either the subtraction or the comparison because if our objective is only the flags, then they are the same. The compare and the subtract instructions, they're exactly the same, but how they change the flags. The only difference is the subtraction will also change the second operand, whereas the compare does not change the second operand. Okay? So I'll just give you this one question here, and I know you guys are really in a big hurry to go. So if I say, this is the original instruction, and I restrict you to only use, okay, your restriction is to use move L and add L instructions. Okay, let's not even restrict the width of the instructions. Okay, and only use direct, register, and indirect operands. How do you accomplish this? And I will also have to say, assume all registers are free to be used. Okay? It doesn't have to be. In this case, you can trash EAX, to do it. Okay, so how would you do this?
Copy the address we want into EAX and then subtract 6 from it.
Subtract 6? Subtract negative 6?
Add negative 6?
Okay, so what you can do let's say EBX is one of the registers that you can use. What you can do is to move 6 into EBX, add L, EAX to EBX, and then you can say move L, $5 to indirect EBX.
But we can't use immediate operand.
Yes, you can.
You didn't say so.
Oh.
Yeah.
That's where I was confused. How we get 5 in there?
Okay, that was meant to be immediate. I said, direct. Okay, is that okay? So basically, you will turn one single cisc instruction into multiple RISC instructions, or vice versa. I can give you a bunch of RISC instructions, and you can combine them into fewer cisc instructions. The bottom line is you have to understand how the address is computed with all the memory operands. And once you understand how all those are calculated, you can convert between the two, cisc to RISC and RISC to cisc. That should not be a very big problem of doing the conversion, because they're all additions for the most part. In fact, they are all additions. But Tech, you're wrong. There's a multiply by 2 and a multiply by 4. Can you do multiplication by addition?
Yeah. Add to itself.
Add the self twice, or 4 times, or 8 times, or 16 times, or.
Yeah. Okay. So, are there any questions? So I'm just giving you, one additional example of what may be in the test. Yep.
Is there going to be any other material on the test, like for example, the jump instruction or the add with carry?
No, add with carry will not be there. Subtract with borrow will not be there, and the jump instructions definitely will not be there.
Do you know how many questions?
It'll be about 4 or 5, so this will be the same extent in terms of the number of questions.
Are we allowed to use jumps if we want?
Okay, I think I have to write very clear instructions of, okay, these are the only instructions you can use.
Well, that'll give us too much of a hint.
But then I can say no op and some of the instructions that has nothing to do with the whole
But you should say, you can only use these instructions, but you have to use all of them.
Okay. Do you have a question?
Oh, I was looking for the paper that they'd be passing out.
Nope, we don't have a sign-up sheet today. We don't have a roll sheet. Oh, do you want to March? The March in March or the sign-up sheet?
I don't know.
There's no roll sheet today.
Okay.
The sheet that was being passed around is only for the, would it be a march, a student march to basically, say we don't like the fee hike?
Oh, that's what the.
That's what the paper is about.
I got that from the sex sheet too.